All right, here we go. 1.7 video notes. Last section of the chapter. So we're finally wrapping up chapter 1. And let's go ahead and let's get after this. So 1.7, the title of the section is Transformations. Now you might notice that the notes are in a little bit different format. We're kind of using a practice worksheet, and we're going to work backwards and do our notes from that because I think it's a little easier with examples. So 3 different types of transformations. Number 1, hopefully you learned this in middle school or elementary school, but the first one is a translation, which is basically just a slide. You take a shape or an object and you just move it up, down, left, right, or on an angle. Second transformation we're going to look at, and we're also going to see this in today's lesson, is a reflection, otherwise known as a flip. And then one that we're not going to see today, but we will see later in the course, is a rotation, where you rotate in a circular fashion around a given point. So some things we have to be able to do today: we have to be able to graph, we have to be able to draw a rule or write a rule for a translation that happens. So we got a lot of stuff that we need to cover. Alright, so graph the image of the figure using the transformation given. So first of all, this triangle right here, this starting point, is called the pre-image. So I'm just going to write over here to the side, pre-image. That is the before shape. So this black triangle here, HDZ, is referred to as the pre-image or the before image. And we need to do a translation that goes 3 units to the left and 3 units up. So every point. So I'm going to start here at point H. It's going to go 3 to the left. And this new point is going to be H with a little 1 up here, which we call H prime. So when you read this, you would read this as H prime. That's all that little 1 means. So there's H prime. And actually, I didn't do 3 units up though, so let me correct that. So H prime is 3 units over, 3 units up. So we'll put H prime up there. And then we got to do D. So D is going to go 1, 2, 3 to the left, 1, 2, 3 up. So there is the new D, or D prime. And then Z is going to move 3 units to the left and 3 units up, which is going to be right here, and this will be Z prime. Now we're going to draw the new shape. And something that should be true, if everything went the way it was supposed to go, these 2 triangles should be congruent to each other. Okay, so one thing I want to write in here, triangle HDZ, and the order of the letters is not important on the first triangle. Triangle HDZ is definitely congruent to triangle H prime, D prime, Z prime. I just want you to realize that when you do a transformation, it does not change the shape of the actual figure. It stays the exact same. So we're going to do it again over here, moving a little bit quicker. 4 left and 5 down. So 4 left, I'm going to move R to there. That'll be R prime. J is going to go, and again, I forgot to go down. Did that 2 problems in a row. 4 left and 5 down is going to put me right about here. So there's my new R prime. J is going to go 4 left and 5 down. So there's my new J prime. And A is going to move 4 left and 5 down. And that's going to put me right here. And I draw the new triangle. So again, this triangle over here is called the pre-image or the before image. And the blue one is called just the image. So I'm going to write that over here on example 1, 2. This is just the image. So we have a pre-image and we have an image, and it moved a certain amount left, right, up, or down. Now we're going to move on down to the next couple examples. You can get into the rules a little bit more. And so on these translations here, they're going to write a little bit more formal. So basically when you read this, it says the original XY points, and they're referring to B, they're referring to J, and they're referring to A. It says what's going to happen to x is it's going to go to x plus 3. Well, on the x numbers, when I add 3 to it, that's going to move it to the right. It's going to move it to the right 3 spaces, because on the x-axis positive numbers go to the right. So every x coordinate we're going to add 3 to it. Now the long way would be to actually write out all the coordinates and do the rule, and I'm going to do that here for the first one. So let's just write down our coordinates. Right now we have B, we have J, and we have A, and B is at, looks like -5, +5. J is at -5, +3, and A is at 0 and up 4, so 0, 4. So now I'm going to go ahead and I'm going to make the transformation. So let's kind of apply the rules up here at the top. I'll do this part in red. So now this part, I'm basically going to add 3 to the x coordinate. So my new B prime, when I add 3 to that x coordinate, that's going to put me at a -2. And my y number, I got to do y subtract 3. So with the y number, I'm going to come over here and I'm going to take away 3. So 5 take away 3 is 2. So let's kind of see where it moved to. My new B is left 2 up 2 is right here, and that's my new B prime. So if you look at what happened, B really went right and then it went down. So when the x is affected by a positive number, it's going to go to the right. And when x is affected by a negative number, a subtraction, it's going to move to the left. And the same thing with y. When y is positive, it's going to go up. And when your y is negative, it's going to go down. So let's go ahead and finish out these points. So -5, I add 3 to it, I get -2. The y value, 3 take away 3 is 0. So I'm going to go -2, 0. And this is my new J. And my new A is I add 3 to 0, which gives me 3. And I subtract 3 from 4, which gives me 1. So over 3, up 1. And if everything went right, I should have the exact same shape, just translated, 3 to the right and 3 down. And it looks like that's looking pretty good. Let's go over to number 4 and let's try to kind of speed this up a little bit as we get better. So looking at my x's, I see that I'm subtracting 6. Remember, x controls left and right movement. We're subtracting. So I know every point's going to go left 6. And the y controls the up or down. So this y, since it's positive or +4, I'm going to go up 4. So basically, every point's going to move left 6, up 4. So let's just do it. Left 6, up 4. Going to put me right there. That's the new A. Q is going to go left 6, up 4. Now I kind of cheat a little bit too. Instead of counting way over left 6 and up 4, I can also look at the relationship between these 2 points. They're 3 down and 1 over. So I could kind of cheat and come 3 down and 1 over up here, as long as my first point's right. If my A was bad to start, that's going to affect everything else. If you notice my N, it's 3 over, so I'm going to put it 3 over, and hopefully, if I'm careful, every point really did go left 6, up 4. I just didn't move all of them separately, because sometimes I can look at the orientation of the original picture over here and help me with my new image. All right, this writing right here, this is referred to as a rule. All right, so if you're ever asked to write a rule, that is the notation, and it kind of reads like every x comma y transforms or translates, and then it kind of writes the new ordered pair what it would be. But that whole expression there is called a rule. All right, moving right down, let's look at reflections. Reflection is a flip, and for this one we need to do a reflection across the x-axis. So here's our x-axis, and imagine if it was a piece of paper and we could fold it on the blue line, and we want to know where the triangle is going to end up. Basically, how you're going to do this, we have a triangle up here that is our pre-image, and we need to flip every point down. So I'm going to kind of locate the points. Well, point L starts out right on the line. So if I folded that, the new L is going to still be right on the line. So this is also, L and L1 are actually in the same exact position. Now D, if I were to fold it, it's going to travel straight down. 1, 2, 3. It's 4 away. So 1, 2, 3, 4 away. So here is my new D, or D prime. And then my other letter, which I got to erase here to see it, it was a T. That one is going to be right over here. And again, I have to make sure that it's the same distance away from the symmetry line, or the fold line, as it was in the upper part. And again, it should be congruent to each other. A reflection does not change the shape of an object, so the two triangles should still be the exact same shape and the exact same size. Now, reflection across the y-axis for this example. So here is my y-axis, and I'm now going to have to flip this point the other way. So I'm going to, W doesn't move, it's going to stay there. M is going to go all the way to the other side over here. And since F is 3 spots away, it's going to be 3 spots away. And that's my new F prime, my new M prime, and this point stays as W prime. And I can connect the dots, and it looks like that triangle would fold on top of itself. Now, if you notice, let's just kind of really quick look at the coordinates. F was at 3, 0. The new F prime is at -3, 0. And let's maybe look at M1 too. M and M prime. My original M was down here, which is right 5, down 4. My new M is left 5, which is -5, down 4. So you can kind of write a rule for when something reflects over the y-axis. In general, the rule is your x, y moves to, notice my numbers up above, the y value never changed on any of these. 0 to 0, -4 to -4. So in my new ordered pair over here, nothing happened to y. Y still stayed y. But if you look at the x's, the x numbers changed, and they changed their sign. So this would be a rule to represent a reflection across the y-axis. Going back to the last example, a reflection across the x-axis, if you notice, all of the x values stayed the same. So x values stayed x values, but y values changed their sign. So that's the different rule between reflection across the x-axis and reflection across the y-axis. All right, moving down to the next page. Now we're looking at reflecting where it's not necessarily one of the axes, but it could be a line. And this is going to test our algebra a little bit. I got to reflect across the line x equals -1. So where is that line at? Well, you go to the x-axis and you go to -1, and that's the line right there. So there's our reflection line. It's on the x-axis at -1, and now we're going to reflect all these points. So here's J, it's 2 spaces away, so I come 2 spaces over, that's J prime. A is 2 more beyond that, A prime. K is 1, 2, 3, 4 spaces, so 1, 2, 3, 4 spaces right here, and that's K prime. So here is my new image, a reflection over the blue line there. X equals -1. Same idea over here in number 8. Reflection across the line y equals 1. So here's the line. I hit the y-axis right at 1. And I need to reflect across that. So we'll do this pretty quickly. C is 1 spot away. So there's my C prime. U is 1, 2, 3 away. So 1, 2, 3, that's my U prime. And B is 1, 2 away. So I need to make B prime 2 away. Connect the dots. It looks like C got in the way a little bit there. But again, it does look like it's symmetrical. And this right here sometimes is referred to as a line of symmetry. Sometimes I just call it a fold line. That'll work too. And sometimes it's referred to as a mirror if you're using geometry software. Alright, let's slide down and knock out these last couple. Here we have to look at a picture and we have to write the rule. And this one is the one that trips people up a little bit when we get to the chapter test, because if you don't really pay attention to the little primes and the letters, it's unsure which direction it went. So you really got to be careful. If you notice, this is the pre-image, this is the before image, this is the after image. So basically, I have to start at the pre-image and move to the actual image. So I'm going from black to blue on this one. So my point V went 1, 2, 3, 4 to the left, 4 to the left, and then it went 1 down. Well, how can we write a rule to describe that? Well, let's give it a shot. X comma Y, my original. Maybe I should even put this in black because we're talking about the black triangle down there. My pre-image became, and then here's where we have to do some adjustments. Well, our X values, we moved 4 to the left. So that means I have to subtract 4 from the X values. 1 down, that affects the Y value. So we have to take away 1 to go down. So what we just did, we wrote the rule. That's what's called the rule. Very careful though what direction you're going. So looking at this next one, it looks like a point G, and really you don't have to test all the points. You can just pick one point because they all should do the same thing. This G value went over 5, 6, 7. It went 8 to the right. Now it did not move up or down at all. So when I write my rule for this one, my XY became, well, moving 8 to the right means I'm going to add 8. But it didn't move it all up or down. So Y is just going to remain Y. There's no change there. So there doesn't have to be an adjustment to both letters. Alright, finishing this guy up. Down here at the bottom, and I don't think I'm going to do all 4 of these because they look very, very similar. Matter of fact, I think I'm only going to do number 11. So let's take a peek at number 11 and find the coordinates. So this is without a picture. We should be able to simply look at the rule, make the addition or subtraction moves, and write new coordinates. So what they want me to do is they want me to come up with the new U, U prime, the new Y, or Y prime, and the new A, A prime. And what I have to do is I have to use the coordinates up above and do the math. So -4 is the X value, and we're adding 1. So -4, when I add 1 to it, becomes -3. -5 when I add 1 becomes -4. And -3 when I add 1 becomes -2. So I took all the X values, I added 1 to them, and rewrote them. Now we're going to look at the Y values. Y started at -3, and I need to subtract 2. So a -3, take away 2 more, that's a -5. A Y value of 2, take away 2, well, that puts me at 0. And finally, another Y value of 2, subtract 2, takes me to 0 again. So I've now rewritten the coordinates. I didn't have a picture, I didn't have a grid, but I used the rule to manipulate the ordered pairs to make it actually perform a translation. And just to let you know, if you were kind of wondering, well, where did this transformation really go? It really went right 1 because of the +1, and then it went down 2 because of the -2. So I'm not going to do the rest of the examples here because they're all very similar. but you'll get a lot more practice on the 1.7 practice tomorrow in class. See you tomorrow.